Ladies and gentlemen, welcome back for our second lecture. And if you are looking forward to seeing nothing but the back of my hand, I'm sorry, I'm going to use a different format from now on. And maybe I shouldn't apologize. Maybe that's a good thing. I think this is going to be a much better format. It's going to work better for all of us. And I'm going to be able to put out more lectures at regular intervals. So let's continue where we left off. Oh, by the way, it's a little known fact that in the word number, there's actually an R here. General solution of the Diophantine equation AX plus BY equals C, where neither A nor B are 0. Now here's what we've done already. We've learned how to use the Euclidean algorithm to find a particular solution x naught, y naught for the Diophantine equation AX plus BY equals the greatest common divisor of A and B. We know how to do this. We also know the general complementary solution of the corresponding equation AX plus BY equals 0. And this is given in terms of xy equals b over d times t and negative a over d times t for all integer values of t. And d here is the greatest common divisor of A and B. And we learned the general solution of the equation AX plus BY equals greatest common divisor of A and B is given by the particular solution x sub naught, y sub naught, plus the general complementary solution b over d times t, negative a over d times t for all integer values of t. That we've learned how to do that. And we had some homework exercises that I sent out in the email on March 20th at 11:59 a.m. I had 2 homework exercises that were part of the email itself. And the 2 homework exercises were of the type where we find the general solution of an equation of this form, a Diophantine equation of this form. Hopefully you did those exercises. If you haven't, by all means, go through the video again and then do those exercises, because those two exercises in the email that I sent out March 20th, 11:59 a.m. are a very important stepping stone to us being able to solve the general solution, or to find the general solution of the Diophantine equation ax plus by equals c. Now I'm going to ask that we recall something else, and this was not from the videos. This was from the period of time when we were actually still coming to class before spring break. If a and b are integers, non-zero, then the set of all linear combinations of a and b, where x and y are also integers, the set of all linear combinations of a and b is exactly the set of all whole number multiples of d, where d is the greatest common divisor of ab. So the set of all linear combinations of a and b is the same as the set of all whole number multiples of the greatest common divisor of a and b. Now, there are consequences to this. The linear combination ax plus by, where x and y are integers, cannot yield an integer that is not a whole number multiple of the greatest common divisor of a and b. Any linear combination of a and b has to be a whole number multiple of d. It is impossible to have a linear combination of a and b that is not a whole number multiple of d, the greatest common divisor of a and b. So here's our second consequence. And when I say not all equations, I'm talking specifically of Diophantine equations. In other words, those equations that admit only integer solutions. So not all Diophantine equations of the form ax plus by equals c have a solution. So only those Diophantine equations only those Diophantine equations of the form ax plus by equals c, where d divides c, have solutions. So I guess if we're trying to solve an equation of this type, the first thing to do is to check and see whether d, the greatest common divisor of a and b, actually divides c. If d divides c, then the equation has a solution. If d does not divide c, then the equation does not have a solution. So the first thing to do if we're trying to solve a Diophantine equation of this form, the first thing to do is just to make sure it can be solved in the first place. We don't want to spend 25 minutes trying to solve an equation that doesn't have a solution. So the first thing to do, compute the greatest common divisor of a and b. And then second, check to see whether d divides c. If d does not divide c, stop. There's no solution. If d does divide c, then we can continue. This is why those two homework exercises attached to the email were important. Once we've decided that the equation can be solved, our first step is to find a particular solution for the equation ax plus by equals greatest common divisor of a and b. Now, this is not the equation that we're trying to solve. This is the equation that we're trying to solve, where d, the greatest common divisor of a and b, divides c. We're trying to solve this equation. But in order to solve this equation, we have to solve this equation along the way. We have to solve this equation first. So we're going to assume now, I guess, that d divides c, and that we have a particular solution for that equation. Now, the fact that we've gone this far indicates that d, the greatest common divisor of a and b, does divide c. Let's see, what would I like to call this number? M, okay. There exists some integer m. Since d divides c, there's some integer m such that c equals d times m. That's important. Plug our particular solution, x naught, y naught, into this equation and multiply both sides by m. If we do, here's what we get. Now, I'm going to distribute the m in a rather insightful way. I'm going to take the m and multiply it by x naught. I'm going to take the m and multiply it by y naught, so that the values of a and b, or the identities of a and b, are preserved in this equation. So I'm going to get a times mx naught plus b times my naught is equal to, let's see, what's d times m again? D times m is c. Oh, son of a gun. So now we have an x value and a y value such that ax plus by equals c. So xy equals mx naught, my naught is a particular solution of the equation ax plus by equals c. We got to call it something, so I'll call it x star y star. Okay, we've got a particular solution of our original Diophantine equation, and we've given it a name. We've given it a name. We're calling it x star y star. An interesting thing about this is that even though we had to find a new particular equation for ax plus by equals c, the complementary solution stays the same. And we get the general solution for ax plus by equals c by adding this complementary solution to the particular solution x star y star. It's that simple. But notice that in order to solve something like this, an important stepping stone was knowing how to solve the equation ax plus by equals d, where d is the greatest common divisor of a and b. Okay, I think it's about time to do some examples. First thing we got to do, make sure that this equation actually has a solution before we bust our backs trying to find a solution that doesn't even exist. So, let's see, 42 is 6 times 7, 30 is 6 times 5. So these two both have a factor of 6 in common and no others in common. So greatest common divisor is 6. Does D divide C? Here's C, it's 10. And D is 6. 6 does not divide 10. No solution exists. So that's the end of that problem. That is definitely the end of that problem or that exercise. And aren't you glad we actually checked to see whether D divided C first before we used the Euclidean algorithm to try to express a linear combination of 40 and 32 that gives us 10? We would have done a lot of work for nothing. Now, we'll do an equation that probably can be solved. At least I think it can. First thing we do, compute the greatest common divisor of A and B. Ah, 15 is 3 times 5, 24 is 3 times 8. 5 and 8 have no factors in common. So 3 is the greatest common divisor. Okay, let's see. D is 3. And C is 21. Well, 3 does divide 21. Okay. So this can be solved. So we're going to find a particular solution to the related equation ax plus by equals greatest common divisor of A and B. Okay, this turns out to be, let's see, this turns out to be our second homework problem in that email. So if we did the homework, we found out that x equal -3, y equal 2 is a particular solution of that equation. Now, this is probably a little bit more detail than we need. We have a solution to the equation 15x plus 24y equals 3. So what are we going to multiply both sides by to make the right-hand side equal 21? Let's see. 15 times, what is x naught? Negative 3. And I'll just write that out large. We have a particular solution for this equation. Here's our x naught, here's our y naught, and here's d, the greatest common divisor of a and b. We're looking for a particular solution, 15x plus 24y equals 21. We want this side to be 21. So what are we going to multiply both sides of this equation by to make that thing equal to 21? 7, right? So 7 times garbage equals 7 times 3. And we're going to distribute 7 in such a way that the identity of A and B are preserved. We're going to take 7 and we're going to distribute it here and here. And let's see what we get. Tell you what, let me erase the top of the board and let's see what we get. Okay, 7 times negative 3 is negative 21. Seven times 2 is 14 equals 21. So we have A times X star, B times Y star equals C. And let me just do a quick check and make sure that this works. Let's see, 15 times 20 is 300. And 15 times 1 is 15, so this is negative 315. Okay, 24 times 10 is 240. 24 times 4 is 96. What was this one again? 210? Let's see. 315, that's what it was. Negative. 336 minus 315, 21. Yep, okay. So we got ourselves the particular solution. Now the complementary solution is the same regardless of which equation we're solving. Complementary solution is equal to b over dt minus a over dt for all integer values of t. So, general solution is going to be x star y star plus b over dt minus a over dt for all integer values of t. You know what? Before we go any further, I should have actually beat this to death. I should have made note of what the particular solution was. Maybe I did, and I just don't have it on the board, so I don't remember. This is rather a belated observation, but please stick that in your notes because we're going to use this particular solution down here. So when we find the particular solution for ax plus by equals c, we're going to hang on to it and use that to form the general solution. I'll give you a minute or two to write that down. Okay, so let's see, we have negative 21, 14, plus that complementary solution. Holy moly, I didn't say what the complementary solution was either, did I? Okay. Yikes. B over D, that's 24 over 3. Negative A over D, so that's negative B over dt, negative A over D, t, h, negative 5, 8t, negative 5t, for all integer values of t. This is our complementary solution. My goodness, forgive me please. When I got the particular solution, I should have circled it like this and highlighted it. When I got my complementary solution, I should have highlighted it like this. Forgive me. Hopefully there's room in your notes to do that. We can also write it like this and combine these two things component-wise. Negative 21 plus 8t and 14 minus 5t for all integer values of z. And let's see, did that make it? Yep, okay. So here is our general solution. And what the heck, let me just play around with this for a minute. We're done with the exercise, but let me just play around with it for a second. Let's see, what was my equation again? 15x, 24y. Minus 5t. Let's just take t equal 3. So we have negative 21 plus 8 times t. And we have 14 minus 5 times 3. What is that? Negative 21 plus 24 is 3. And 14 minus 15 is negative 1. Okay, let's check. $15x plus 24y equals, that's 45 minus 24 is 21. Check. Okay. So any integer that we plug in for t will yield a solution to this Diophantine equation. Ryan, we can even plug a ham sandwich in here, And as long as it's an integer ham sandwich, it will yield a solution. Any integer for t will turn this into a particular solution. So there are infinitely many solutions to this Diophantine equation. Now, would I let you go without giving you some homework? No. Probably before you finish this exercise set, I'll have another video up giving you a little bit more instruction on problem solving using Diophantine equations. But for now, review this video carefully. Take notes like you were in class, and work through the computations and so forth that we did. Make sure you know exactly what's going on here. Get plenty of rest. Be productive. Work on schoolwork. I told my differential equations class that in the book of Ecclesiastes it says, "There is nothing better than for a man or a woman to see good for all their hard work." So if we work hard, that we should be able to enjoy the fruits of our labor. So work hard on this. We're going to make just as much progress in this class as if we had never had to disappear for 3 weeks or however long we're going to disappear. We're going to learn a lot about number theory, and I am eagerly looking forward to the day when I come back and instead of being in an empty classroom, you're all going to be in front of me in very good health and of a good frame of mind where we're going to get back to work. Although actually we should get back to work before that time. Work on this. Give it your earnest effort. Work hard and enjoy the fruits of working hard. Exercise soundness of mind in all you do. I'm looking forward to seeing all of you back in perfect health.